9.5 distance on a coordinate grid with approximating. So we're taking both skills that we learned in two separate parts and putting them together as one problem. So here we have our first example, number 1. So we're going to approximate the distance between -4, 3 and 3, -5 to the nearest tenth. So we have to watch out for that, the tenth. So if you don't have graph paper, pause the video and go get some graph paper so you can plot these points. Welcome back. So sometimes these points will be labeled A or B or X, Y, or sometimes they have some fun names like um, boy, BOY, or math, MATH. So some fun names, but so you could name it a point A and point B, or like in a word problem, it might be like City Hall and the park. So you're looking at that distance between those two. So we're going to draw a line. We want to find that distance between those 2 points. And on a coordinate grid, we can always see that we have, oh man, I need to work on my straight lines here. So I'm going to make my points a little bit more visible. So we're going to look at our right triangle here, and notice it's not that pretty, but I know it's a right angle because it's on a coordinate grid. So I know this is a distance of 2, and this one's a distance of 2, 4, 6, 7. So I've got a 7 and a 2, and I can label those now because it's a right triangle. This one is my C, and I remember this is A. I like to have this one A and this one B. So now I'm going to go into my calculation mode. Solving mode is number 1 is formula. So the a squared plus b squared equals c squared is my formula. And now I substitute as number 2. So 2 squared plus 7 squared equals c squared. Now I solve. So that would be 4 plus 49 equals c squared, and that would be 53 equals c squared. And I'm still solving, so to cancel out this square root, I need to take the squared, I take the square root of both sides to cancel that out. And, now c equals the square root of 53. And this is the exact answer. Notice I still have an equals. This is our exact answer right now. So if it had asked, instead of saying approximate, if it said exactly, that is what we would use. We would circle this one. But it says approximate. So now we need to go into our approximate mode, which we learned that was the square root of 53 is in between. Now I like to do the 49 was just below it. That's right. So the square root of 49 was 7. So the one above it has to be 8, which is 64. So now I'm thinking, okay, so I have a total of, how much is that? I've got 49 to 53, so that would be 4. And then we've got, how many more here now? 11 more up here. So that's a total, so now I'm going to go approximately, and we're going to use that squiggle. So I'm going to change my sign here to approximate, because when I get my decimal, it's going to be approximately. So it's going to be somewhere between 7 and 8. I know it's closer to 7. So that's going to be approximately, it's 4 out of 15. So I'll use a little bit of sideline math here. 4/15, which would be 4 goes into 15. No, other way around. 15 goes into 4. What am I thinking? 15 goes into 4. I was trying to think of a lot quicker way ahead of myself. So that would be 30 would be 2. 3 would be 45, so I need 2 of them. So that would be 30 minus would be 10, bring another 0. I have to go to the next place value to make sure if I have to round up or not. So 2 is 30, 4 would be 60, and another, I'd be 90, so that'd be another 2 would be 6. 6 times, 6 times, 30. 6 and plus 3 is 30. So that would be would be another 10. So that tells me that I would take and round that 0.2 up a little bit more. So when we remember we were close to the 7, so it would be 7.3 units. And notice how there's a little bit more math that we have to do. So this would be on a non-calculator day that we would have to do this. Before we were allowed to use that calculator to just punch that into the calculator and calculate that out. But what we're doing is estimating, and this estimating process gets pretty close, and it's pretty close. So our next example, we'll do number 2. Will be very similar, exactly the same. So if you want, you might want to pause the video and see if you do it or practice it and do it again, or you could follow along. So I'll put my first point at 1, -1, 5, 2, 4, 5, and 4. Ooh, it's a little bit trickier because it's in a totally different quadrant. So we're going to find that distance all the way across here. And remember, that is always our C. It seems to always be our C because when we make our triangle down, that right angle comes across, it will be always that C right there. So my distance then is 2, 4, 5, and 2, 4, 6, because there's 5 over and 1 more is a 6. Now remember, we're not necessarily doing the positive and negatives because we're not looking for the slope of our line. We're just looking for the distance. And remember, it's always going to be squared, so it's always going to be a positive answer. So we'll call this one A and this one B. So we're going to start with our equation, our formula, a squared plus b squared equals c squared. And then we do our substituting. So 5 squared plus 6 squared equals c squared. Now we'll solve. 25 plus 36 equals c squared. That would be 11 and 61. 50, 60, 61. Equals c squared. And so now what we're looking for is our taking that square root of both sides. And we take the square root to cancel out that squared. So the square root of 61 is our exact answer. And notice how I said exact answer as I was writing down my equals. And that's what I think in my head is exactly 61 squared is our length. Now it does say we want it to be approximate, so I'll do my little sideline math here. 61, it's that 64 again. And below that, it was 8 up here, so down here it's 7, so that would be the square root of 7 times 7 is 49. So that's a good way to kind of work your way around in kind of a bigger C shape. So now I'm going to look at this is approximately, so I'm going to put my squiggle, and that's going to be 3 away up here. So that would be a plus 3 away, and I think it was 15. Yeah, it was 15, so that would be a 12 away. So we're going to take, and our fraction would be 3 out of 12. 3 out of 12 is 1/4, which equals 0.25. Perfect. I love when they work out like this, and it's a nice, simplest way. So that tells us that it's going to round up to the tenths place, which would be 0.3 would be our approximate. And notice how I'm using the squiggles. So now I'm going to, that means, oh, this is the tricky one. That 0.3 was the 3/12. So remember, where was that 3/12? That 3/12 was right here. So that means we have to go back or not 3/12. Yeah, 3/12 or 3/10. It's approximate 3/10 rounded. And so that we're not going 7.3, and that's the common mistake to do is to go up because, well, you would have to have done 12. Oh, you know what I just realized? I used the wrong number. So I'm going to have to go back a little bit, and it was supposed to be 15, which means this isn't 0.3. It was supposed to be 3 out of 15 because that was the total that we had here. Oops. Okay, good thing I noticed that. And that sometimes happens in mathematics is you realize partway through and you're like, oh. And so it's an easy fix. Notice my structure stays the same, and it's 1/5, which I can think of it too as 2/10. So this one, we were close, but we were a little bit too big for our problem. So it's approximately 2/10. So instead of 3/10, it's 2/10 away. So back to what we were thinking, that distance is 2/10 down from 8 because we were thinking about that 3 over here, that 3/15 was down from the 8. So that would be approximately 7.8 would be that problem. Now, if you didn't want to have to think about that part of it, what you should do is instead of doing the 3 up here, you should do the 12/15. So doing that, because you're always coming from that lower 7 side, the lower 7 going up. So you're just going to add the decimal. So that would be approximately, 3 goes into both of these, 5, and 3 goes into 12 4 times, so I'll multiply those to get tenths. 8, so that would be that 8/10 approximation here. And then it's just you add the decimal to that. So if you want to just not worry about that subtraction up here, you just want to put in that lower part of that. So now that we put it up here, we found the estimate, approximate. Now remember, we're going to have to change our equals to approximately 7.8. Oh, and we need units as our label.